Inventions Caucus Advisory Committee, along with the Robotics Caucus Advisory Committee, and that's in conjunction with the Congressional Inventions Caucus and the Congressional Robotics Caucus.
If there's going to be a seat for intellectual property on planet Earth, it should be the United States of America. If there's going to be a government that invests for the next generation instead of this generation, it should be the United States of America. If there's someone who is going to listen to folks who know more about moving forward than perhaps the folks on Capitol Hill who do lawyering for a living, it should be the United States Congress.
Just really quickly, I'm going to tell you a little bit about what we do at NASA and then where we've invested in robotics and particularly in a national robotics initiative. We're the cross-cutting technology program for the agency, so we develop technologies that enable human exploration of the solar system, advanced robotics exploration of the solar system, capabilities for other government agencies, and enable a more robust commercial space enterprise in the nation. And so we're looking for technologies that cut across all those mission areas and capability areas. One of the things that we'd like to do eventually is land a robot on, say, a ocean worlds planet like Europa and explore what we would call an extreme terrain environment that we're probably not going to know a lot about. And eventually we'd like to send a penetrator down through kilometers of ice and maybe a robot submarine down below the ocean of Europa and look for life on that planet.
The robotics field is undergoing a very rapid change. In addition to many startups, many applications, some of the startups being represented here incidentally, we have major players who are not in the traditional robotics field, such as Amazon, Google, Uber, and so forth, entering the robotics field in a major way. As the robotics field, and especially the robotics industry develops, we need to supply the workforce for this industry. We need to do so at all levels, not just at the graduate level, including at the master's level, at the undergraduate level, and at the professional degree level.
We produce software that allow robots to see, think, and do. We have 6 patents. We are real aggressive in patent filings. We just filed 8 patents. And we were the first ones in North America to receive the first single camera 3D vision patent. We're suggesting these 10 things. 1, identify key areas for growth and innovation for the United States government. Provide meaningful funding to small businesses in those areas. Structure payback with royalties, not equity. Equity is simply too expensive for a new business owner. 4, provide incubation for small businesses in key areas like office space, lab space, and maybe consultative services. 5, introduce the technology to government users. This only makes sense. Create partnerships. Coordinate universities with government, with high-tech companies. 6, provide guaranteed revenue from the government up to $500,000 annually. 7, eliminate the capital gains taxes for small IP-rich businesses. 8, eliminate taxes on royalties for small IP-rich businesses. 9, understand Industry 4.0 and its technologies that form its foundation, and there are 9 of those technologies, and robotic automation is at the top, number 1. And last but certainly not least, protect intellectual property and protect those rights worldwide. Create stable treatment of patents as durable goods.
When people ask me what should the next great mission of NASA be, the next Apollo program, very high on my list is the idea of setting up a self-replicating factory on the moon or on the asteroids. Because if you do that, then by the time you actually send men there, of course, there'll be the cities, all built by robots. And that's also something where you could get people on Earth involved in the prototyping. They could design their thing, get it to work, transmit the instructions, and see it working on the moon.
We are HK Robotics, and we're out of Hawaii, is where our primary area of business is located, for the primary mission of removing unexploded ordnance from some of the surrounding impact zones that were used during the war for training. So we built this product behind me, this magnetic metal detector, flying metal detector, to do just that. Intellectual property is our primary concern, because if I tell anybody anything, if it isn't patented, either the Chinese will steal it, the US will take it. What's the point of inventing if I don't get either the credit for it or money from it?
So this is a Carl's Jr. Yeah. it has a large tactile sensory area here, so it encourages people to communicate with him through touch. We are trying to build some interactive game for the kids with HD or ASD.
Our laboratory was a pioneer in the field 20 years ago when we started using robotics for the purposes of rehabilitation after neurological trauma such as stroke or spinal cord injury. One of our technologies we brought with us today, since we can't fit most of the really big robots through the door, is something called the music glove. If we're going to move this into the market, then we need to be able to make sure that it's our own. No one's going to want to invest in something if they think that someone else can come along and build the exact same thing.
So what we actually brought here today are a couple of different robots that our lab has built roughly over the last 20 years. The snake robot that I'll show you here has a very, very small cross-sectional area, and it's very good at weaving its way in and out of things like a collapsed building, if you want to think about it that way. The legged robot you can think of as sort of its bigger brother, and it can crawl over rubble, and a lot of the science that the three of us develop is really based on sort of the autonomy of getting these things and enabling them to actually move around in very, very complicated environments without having to rely on sort of a supercomputer to figure out what's how to actually move.
What we specialize in is indoor localization, navigation, and mapping. Well, we want to have robots in every Walgreens in the future in just a few years. And so one of the primary applications that Walgreens wants to work on initially is being able to map out their environments. So being able to say where products are located, where they're located on the shelf, and then be able to have a map model that they can provide to their corporate employees and their store employees as well. So we're really interested in robotic applications that can change people's lives, change the way people interact with their environment, and make life better for people and make life, make experiences a little bit more special as well.
So what we have is a in-ear 3D scanner. It's made for making custom hearing protection, hearing aids, headphones, things like that. We take a measurement of the ear. It's kind of like painting the ear with light. I move this around and get a 3D map of the ear. Once I'm done, we'll end up with a file that we can 3D print. It looks like kind of like this. So these are custom hearing protectors, but they're 3D printed. So we have 9 patents that have been issued. We have at least 36 that are in the works in addition to those 9. So we licensed the technology in those, and it wouldn't be possible without having patents.